one of the problems with pesticides is how do you even know they're there? So Wild Genomics is going to answer that question with Eirik Torheim, and I'm told that if you want to visit him later on, you'll have to go to Norway. With that being said, Wild Genomics, Eirik Torheim.
Thanks a lot. All right, so I'm Eirik from Wild Genomics. I'm the business lead. I have a co-founder, Bilge. She is technical lead. I'll show you where we are at. Let me introduce you to farmer Seth Tillery. He's a organic citrus farmer in Exeter, California. It's a fairly small farm, but he has told us that there's an added cost to growing organically. Still growing organically and applying regenerative farming practices is becoming more and more the norm. At least there's a movement in that direction. The challenge, as I mentioned, is that it's more costly, and you have fewer tools for dealing with pests. But you do manage to avoid the damaging effects of pesticides, and you can also get in early and meet those changes in regulation that we're expecting. So as I mentioned, when you're growing organically, you have fewer tools, and that makes it more important to come in early to manage the pests. And this is where we are supporting our farmers by continuous monitoring and early detection of pests. And that helps the farmers also address these pests at a lower cost. So our value proposition is, one, to save the farmer time. We can save them up to 90% compared to traditional ways of monitoring. Two is to reduce the use of pesticides and reduce the costs associated with applying pesticides. And then even they can have an increase in yield if they apply regenerative farming practices in a good way and have a healthier soil. So the market size we're addressing is represented by the damage caused by pests, which is $220 billion globally. The smart pest monitoring market, which is more like a niche market, is an $800 million market, and we're looking to attain about 10% of that market in North America over the next 5 years, and that corresponds to about $35 million. There's going to be some feedback. So this is our sampling device, first iteration. It's fairly simple. So we basically ship the sampling device to the farmer, and the farmer collects the sample and mail those samples back to us. And then within 72 hours, we get back to them with the data through our web application. And this data allows them to address the issue with a precise intervention, supported by a network of pest control providers that we are integrating with. So our combination of air sampling plus DNA barcoding provides both very high precision and species identification, but also allows us to address a very broad range of pests. So we call ourselves pest agnostic. It doesn't matter what comes in, we'll be able to detect it. At least in theory, we'll prove it in the coming years. DNA barcoding is also a lower cost approach to DNA sequencing, so we can do all of this at a lower cost than the farmers pay today for similar services. So our competitive advantages include, well, one, that we're non-invasive. We don't kill any insects while we're collecting these samples. We can capture a very wide range of species, and we can identify them very precisely. We can also provide early detection through our continuous monitoring approach, and our service is easy to set up and highly scalable as well. So our vision market is California specialty crops. So the barriers of entry into other states are low, and we expect to be able to expand across the nation in a fairly short time. Actually, our first paying customer is in Iowa. He's a soybean farmer. So since all this, the shipping is done by mail, so it's really easy to access the whole country. So these are some projections for our revenue growth over the next 3 years, divided up on those 3 markets. So our mission is to offer precision pest monitoring help reduce the use of pesticides. And to support that, we are tracking some key performance indicators, such as the number of pests that we can identify, as well as the amount of pesticides that our farmers are avoiding using. Our main sales channels are through industry events and referrals. And even though the independent farmers are our end users and currently our main customer, there are other customer segments as well, including the farm cooperatives and pest control advisors. Financially, we're looking to break even in year 4 after 3 years of refining and growing the service. In year 5, we're expecting to be able to provide our service at a cost less than $10 per sample, which is much less than farmers will pay today for DNA sequencing samples. This is our team, 2 co-founders, as I mentioned. Bilge is an environmental DNA sequencing expert. I'm a serial entrepreneur with a long background in life science. I just graduated from Radio School of Management with an MBA. From there, we also have a group of my classmates who've been helping us. And we've started building a strategic advisory board, which currently consists of Dr. Elizabeth Lyons from UCSD and Dr. Ana Maria Moreno, who's a local biotech founder. So this is where we are pretty much. We're currently working on incorporating, and we are running beta testing with our first customers, preparing to raise funding within the next year. I'll leave it there. So anything you can help, in terms of call to action, if you have a way to help us with industry contacts, potential investors, would much appreciate that. Also advice for public funding and so on.
Okay, so I'm going to put a pause on the clock just for a second to let the judges introduce themselves. And also you should see the QR code. I'll move them down there if you judges could scan that and log in there. And of course, to turn on the mics, you just press the button at the bottom, but I'll give Matt mine so that we're ready.
Hey everyone, my name is Matthew. I've been independently investing for about 12 years now. First, I started in stocks and then crypto in the past couple of years, and then more recently a piece of real estate. And that's allowed me to travel the world and research health, wellness, and personal development, which is my passions. So I'm grateful to be here and look forward to hearing the pitches.
Hi, my name is Joe. I'm this second-time judge here, and I'm from Legendary Ventures. We're a $1.8 billion venture fund, and we are industry agnostic, and we look at everything. If it's a good deal, it's a good deal.
Is this on? Hi, everyone. My name is Emmanuel. I'm an entrepreneur turned investor. Spent about 6 years in a software venture capital world, and then in 2017 started a firm called Chisos Capital, which is a super early stage day one investment group, and we have about 70 investments.
Hi, my name is Venki Pegaraju, and background is in genomics, genetics. I've had an opportunity to work with 4 startups and successfully exited. And I'm an entrepreneur resident with UCSD and mentor to a lot of accelerator programs, and also an angel investor in early stage genomics-based startup companies. Thanks.
All right, start the clock. You've got just a few minutes for questions from the judges.
Yeah, so curious, so like you're detecting, but let's say let's say you have a positive, detection of some sort of a pest, and how quickly can farmers, be able to react to that? Are you creating that entire ecosystem, or is it just like the diagnostic aspect of it? And one thing which wasn't really clear to me is, like you said, it's non-invasive. Can you elaborate a little bit more on, like, how would you be able to, like, say, if you have a sapsucker or a chewing insect, how would you capture the sample on those? Thanks.
Yeah, great question. So it's non-invasive because we're filtering air. We're not taking any specimens. We're not trapping any insects. But in the air, there are particles floating, and those particles contain DNA from everything that's living in the area: plants, animals, insects, molds, and bacteria. And we're specifically interested in the insects, the bacteria, and the molds. They're responsible for most of the agricultural diseases. But we can trace them in the air without sampling them specifically. And that also helps us identify pests that you can't even see. So you don't have to see the bug before you can find them in our testing. And you had a question about the ecosystem. So this is our way to get started. We're doing samples are being mailed to us and analyzed in our lab. Ultimately, we'll have a device to do everything in the field, but for now, it's mailed. The data is backed we're using machine learning to identify the best approach to deal with any particular pest situation. And that data will be fed to the farmer within 72 hours of us receiving a sample. And then it'll also be paired with advice on how to deal with that particular pest. And in terms of ecosystem, the providers of pest control measures for that pest, including biological measures like ladybugs for aphids, for example.
All right, time for one quick question.
Hi, Eric. I'm always infatuated with just why entrepreneurs get into this field. And could you tell us a little bit about obviously you've got a background in genomics, but why this?
Well, both myself and Bilge were very passionate about nature. She has the environmental DNA sequencing background. And when we met, we started looking into how can we apply this technology to actually make an impact on nature. And there are many, there's also biomonitoring in forests and wild nature, but this is very tangible. There's a need among farmers to pay for this, or not to pay, but to have this problem solved, and they're willing to pay. So yeah, basically supporting biodiversity and nature through helping the farmers. Sure. I don't think the clock actually stopped, by the way.
What's that?
I don't think the clock actually stopped when you introduced the judges.
Oh, no, it didn't, but
You had another one? Okay.
yeah, I had my own time backing that up. So no, but
we're
that did there. So you got fair measured time. So we talked about decarbonization and regenerative farming, and that's next. So next will be ChloroBoost.